Hello and welcome to Decision Support Systems for Managers. We are into Module 5 Decision Support System for HR Managers and Lecture 3, that is Employee Selection, Promotion and Deployment Methods, Rating and Ranking Method and Clustering. Okay. Now, in the previous lecture we have told you we have shown you how to do the LP method of supplier selection is employee selection. Okay. This LP method is extensively used for multi-criteria decision making. Okay. Now, we have covered these issues in HR and we are taking employee selection, job promotion and employee deployment all together. Okay. Today, we will do rating, ranking and also clustering and comparison of rating, ranking for the time being. Later on, we will do clustering. Okay. Now, under rating method, remember what we did for LP. We had 3 criteria. Now, under rating method, some key personnel are asked to rate the employee selection criteria on a scale of 1 to 10. In our case, we had 3 selection criteria: days absent in previous job, on target and number of days taken to complete project worth rupees 100 crores. Okay. Rating would mean to rate these criteria on a scale of 1 to 10 in terms of importance. That means, we have 3 criteria. Now, for an organization, they might say that number of days taken to complete project 100 crore, that is very important, and they give it 7 on a scale of 1 to 10. Days absent does not matter, work over fine, now be how many days absent you want, you be absent. So, days absent not important. So, scale of 1 to 10 they give a rating of 3. And on target very important. So, they will give it 5. So, 3, 5 and 10 they can 3, 5 and 7 they can give. Okay. So, this is rating method. What is the difference? In LP method we learned that the weights were equal, means so as to say everyone is given equal importance, but here we are seeing that they are given unequal importance. So, under unequal importance what should we do? Okay. 2 criteria can have the same ratings. So, one rating is 7, another rating is 7, that can also happen. Okay. The criteria rating values are to be normalized, just like we normalize the previous table. So, similarly here also we need to normalize. Okay. Let us continue with the previous example. This is shown in the next slide. Okay. This was the original criteria. Okay. This was the original criteria with which we started our employee selection. Okay, right. Now, the criteria ratings are project 100 crore. Okay, so, these were my criteria, it is just one column was shifted. Okay. So, the criteria ratings are days absent in previous job 9, on target out of 2 this criteria they have given 7, and project also they have said no, that is also equally important, that is also 7. So, see the difference in the earlier model, candidates were asked, you give what you are doing, what is it in your previous record, this is this table. Now, the office says, this is the difference, this is the table. Now, the office says the table is fine, the information that they have given is fine, but then you tell that these factors have different importances, rating. Okay. These are the ratings that are there, now you do something. Okay. Now, you will say very simple, just multiply, just like weight, actually it is very simple only. Okay. So, what you do is you add up these 3, 9, 7, 7. Okay. I will just show you, I will just show you. Yeah. So, your rating was 9, 7 and 7. Okay. So, what you do? 9 plus 7 plus 7, 14, 23. So, what is your normalized score? 9 by 23. Okay. So, this is basically your normalized score. Okay. Clear? This is what we will show you now. Okay. So, this is the normalized score, 9 by 23 is 0.4, 7 by 23 0.3 and 7 by 23 0.3. So, normalized value of the weights. Okay. After this what will happen? Normalize the candidate score as per LP method applying max and min criteria just like we did in the previous week. Okay. in the previous lecture, normalize the candidate scores as per LP method applying max and min criteria, right. Okay. We have normalization formula, you remember, right. Normalization formula we had given. What was the formula? Formula was for, okay, let us do the min formula first. Min formula Hj minus Fij by Rj. Rj means what? High minus low, right, that is the range, and max criteria was, okay. So, this was my criteria. Okay. So, we apply the same formula and we get this normalized table. Okay. We apply the same formula and get this normalized table. Okay. Now, you see on top in red, here, on top in red 0.4, 0.3, 0.6 this is the normalized score for the ratings. So, what you do now is just this normalized score for this rating 0.4, just multiply this, everything multiply by this, 0.3 everything multiply, 0.3 everything multiply, okay, nothing else. So, multiplying the normalized rating score with the candidate normalized score, we get this. Okay. Summation of the candidate score, higher the score the better, as simple as that. You sum it, higher the score, it is better. Earlier one was lowers the score, it is better, because what was the idea? The idea was this is my ideal value. How far you are from the ideal value, that is what we were measuring, and the nearest you are to the ideal value, the better, and the nearest means the lowest value. But here you have already given weightage, okay, giving more preferences, more rating. So, what is happening here? Higher the score, higher the rating, better. Okay. The summation of the candidate score, higher the score, the better. Okay. So, candidate ranking based on rating method 5, 6, 2, 7. Okay. Has it changed? We will see. Okay. 5, 6, 2, 7. Okay. Let us go to ranking method. Okay. Under ranking method, some key personnel are asked to rank the candidate selection criteria. Which criteria is more important than the other? Rank 1, 2, 3, etc. Rank 1 being the most important. I am repeating again. Under ranking method, the some key personnel are asked to rank the candidate selection criteria. Which criteria is more important than the other? Rank 1, rank 2, rank 3, etc. Rank 1 being the most important one. Okay. In our case, we had 3 selection criteria: days absent, on target, number of days taken to complete project worth rupees 100 crore. Ranking would mean to rank these criteria in terms of importance. This is organization specific, remember, organization specific. Now, 2 criteria may have the same rank if the organization feels that they are equally important. So, there is no clash as such. The criteria ranking values are to be normalized. Okay. Let us continue with the previous example. This is shown in the next slide. Okay. Same example. Yeah. Now, the criteria rankings are rank 1, absenteeism is rank 1, second one is rank 2, third one is days of completion is rank 3. Since there are 3 criteria, absent will get us weightage of 3, is rank 1, weightage of 3, CPK will be 2 and days of completion will get a weightage of 1. I will explain this. What are we doing? We have 3 criteria. We have 3 criteria, right? Criteria was absent is the first priority, then is your on target, second priority, and then project is third priority. Okay. Absent first priority, on target second priority, project is third priority. Okay. Done. Now, So, first, second, third. So, when you are giving a score, if I give absent as a score of 1, if I give absent as a score of 1, this as 2, project as 3, then there is a problem, na? Because absent will now get less weightage, project will get more weightage. So, it should be reversed. So, absent should get 3, on target 2 and project should get 1. Agreed? If there were 3, 2, 1, if there were let us say 5 criteria, then what will be the scores now? 5, 4, 3, 2, 1. Okay. So, this is the basic difference. Okay. Clear? Then we again normalize 3, 2, 1, total is 6. So, 3 by 6, 2 by 6 and 1 by 6. So, normalized value of the weights. Okay. Normalize the candidate scores as per LP method, applying max and min criteria. Okay. So, normalize, we have already done it. So, we are not going to do again, because we already have the table. Now, why should we do again? Okay. So, now the normalized score we got 0.5, 0.33, 0.17, just multiply. Okay. Normalized score 0.5 into 0.78, okay, just multiply this entire column. Okay. Same principle, no difference. Only thing is the first part is different, nothing else. So, now we get a total score after multiplication. Okay, get a total score after multiplication. Summation of the candidate scores, higher the score the better, okay, and then we sum, so rank, higher the score, because this is different from LP, okay, that one difference, okay, right. So, we get the rank, right. So, here who is the first rank? Supplier, a candidate 5, okay. So, rank of candidates based on ranking method S 5, 6, 2 and 7 is rank 1, 2, 3, 4, 5, 6, 2 and 7. Okay. Now, the question is, we have learned 3 methods, okay. We have learned 3 methods, LP, rating and ranking. The issue is whether are they same, are these rankings same, can it be same, are they same, what will happen if they are not same. So, all these questions will come to us. Okay. Since a count is involved, ranking method is also sometimes referred to as Borda count method. So, this is the summary. As I was saying, LP method, the candidates rank 1, 2, 3, 4 was 6, 5, 7, 2, rating method 5, 6, 2, 7 changed, ranking method 5, 6, 2, 7. So, you see rating and ranking gave similar results, but LP gave different results. Why? You all know, because the weights was different, right. The weights were different. First one gave equal weightage, second one had different weights. Now, the question is, see, look at this table very carefully. I will stop here for a minute. Look at this table very carefully. This is my candidate selection. Okay. Can I use the same table for promotion also, employee promotion? I can select. Okay. I can select the same table for employee promotion also. Okay. Clear? Select the same table, right. Now, see, for promotion, if you can do such a table, employees get employees are there, they are getting a clear picture of where they stand, why another employee was bypassing him to get a promotion. Okay. Now, you see, only problem here is LP method is giving a bit different result. The group remains same, but the results differ. So, if only one person is going abroad, employee deployment, this third point that we are saying, employee deployment. If one person is selected for going abroad, if we are following LP method, it is 6. If we are following the rating and ranking method, is employee 5. So, that creates a problem. Okay. So, the question is, which method is appropriate, which method is not? See, answer is very okay. Let us go. Why are the rankings different? then while preparing a list of candidates will we go wrong for following a particular method? This was the question. See, the answer is very clear. The reasons why these three methods are used are different. When we have a rating scale, we have to use a rating method. When we know that they can be ranked, we have to use ranking method. When we know that all have equal weightage, we can use LP method. Okay. So, they are not one over the other, they are basically for different situations. Okay. They are basically for different situations. Clear? So, there is no overlap as such, there is no clash as such, no ambiguity also. It is just one method is for one particular set of situations, another method is for another particular set of situations. Okay. What do you do when you want a group of candidates as category 1, category 2 and category 3 candidates? Okay. What do you mean by that? Group of candidates? Say a company has got a project, okay, very high value project. Now, immediately you need to form teams and then you have to decide which team should be given that project. Okay. There are sometimes there are already a specific team who works on certain things. So, you have to find out which team can work on it. Again, if you do not give to a particular team, give it to another team, that team gets very unhappy. So, there should be some method. Okay. So, what we are saying, there should be some method in selecting the teams also, right. Okay. What do you do when we want a group of candidates as category 1, category 2 and category 3 candidates? Okay. Good, better, best, good, better, best. Okay. So, what do you do? Okay. Team, not individual, okay. Because individuals high, low together makes a team. Okay. We will use clustering method. Consider the table that we have used for LP rating and ranking method. Okay. Same table. Okay. We are using this. We normalize the values as usual using the same formula, max and min formulas. Okay. Based on the normalized value, we do a cluster analysis. What cluster analysis we do? K-means clustering. We specify the number of clusters to be 3. We can use SPSS for this purpose and cluster membership need to be specified. Okay. Yeah. Okay. Now, I will show you how this is done. Okay. What is happening is clustering, there are different ways, different methods. Hierarchical clustering and K-means clustering. Hierarchical clustering basically goes by this. Okay. In this way it moves. K-means clustering basically says you tell that I want 3 groups or I want 4 groups. Basically, I want this cluster. Okay. So, here basically in hierarchical they converge to one cluster and here it is I only define how many clusters I want. So, for doing any project, if I want that only 2 groups to come up, I will mention that I want 2 clusters. If I want my entire team, my entire organizational IT team to be divided into 3 groups, I will want 3 clusters. If I want 4 groups, I will say I want 4 clusters. So, K-means basically helps us to define the groups also, to define the clusters also. Okay. So, this is what is K-means clustering, right. Now, when you, so that is what we said, we will use K-means clustering and we specify the number of clusters to be 3, because in our problem we have said that we want 3 groups. Okay. We can use SPSS for this purpose. In SPSS, what is done is, I think many of you are already aware and have used SPSS as a software. SPSS, you type in the data, you put in the data, go to clustering in the analyze icon. Under analyze icon, you will get clustering, go to k means clustering, and there you specify the number of clusters. If you want 2 clusters, specify 2. If you want 3 clusters, specify 3. So, you specify the number of clusters that you want. Okay. So, k means clustering. So, cluster membership needs to be specified, that is, specify the number of clusters. Now, once you specify, this table will come. Okay. Just a second. Yeah, somehow this has shifted basically. Yeah, now it is fine. Yes, sorry. Yeah, okay. Now it is fine. I suddenly saw that it has shifted. Okay. So, see candidate 1, now look it very carefully. Candidate 1, I am reading it out. Candidate 1, days absent in previous job, on target, number of days taken to complete the project work. This was the data that I gave SPSS. And I mentioned that I need 3 clusters. SPSS has come up that candidate 1, last column, SPSS has come up with candidate 1 cluster membership is 3. That means he is in cluster 3. Candidate S2 is in cluster 2. Candidate S3 is again in 3. Candidate S4, 6 and 7, whatever, S4, 5, 6, 7, they are in cluster 1. Okay. So, it is clearly mentioned that cluster 1 has 4 candidates, cluster 2 has 2 candidates, and cluster 3 has 2 candidates. Sorry, cluster 1, let me correct myself, cluster 1 has 4 candidates, cluster 2 has only 1 candidate, that is candidate 2, and cluster 3 has 2 candidates, that is candidate 1 and 3. Okay. So, 3 clusters, cluster 1 has 4 candidates, cluster 2 has 1 candidate, and cluster 3 has 2 candidates. Now, my question is that does it mean cluster 1, does it mean the best cluster? Answer is no. Cluster 1 does not mean it is best cluster. Cluster 1 means you have asked for 3 clusters, it has given you 3 clusters, finished. It is based on again the distance. Okay. Now, which cluster is better than the other, that you will have to calculate. Okay. So, yeah, read all the table. Okay. So, now what you do is you take cluster 1 people together, cluster 2 people together, and cluster 3 people together. Okay. So, now you see cluster 1 is taken together, cluster 2 is separate, and cluster 3 is separate. Okay. So, you see candidate S4, 5 and 6 have gone in cluster 1, candidate 2 is in cluster 2 alone as we mentioned, and candidate S1 and S3 is in cluster 3. Okay. So, you have taken them together. Get the average score of each of the clusters. The cluster with the highest average score is the best cluster. Okay. Get the average score for each of the clusters. The cluster with the highest score is the best cluster. So, what is the average score? Total it up, total the row S4, say let us say S4 0.5 plus 1.15, sorry plus 0.15, 0.58, total is 1.23. So, total it, then average, then average of S2 cluster, average of C3 cluster. So, which cluster is better? Cluster 2, that is candidate S2, the single member cluster, he or she is better. Okay. Followed by cluster 1, this group, followed by cluster 3, the other group. Okay. Now, definitely you can see again from this, suppose you have got to do something to improve the clusters. Cluster 3, that is candidate 1 and 3 combined, there is a problem. Okay. So, might be some redeployment might help to increase the average score. Okay. So, that is also possible. So, some redeployment, that is also possible. Okay. So, this is there. So, this is the way by which you do clustering technique. Okay. So, S2 is the best cluster, this is the second best and this third best. So, moment you see also see the huge difference in score. Cluster 1 has a score of 2 and cluster 3 has a score of only 1, that is 1.03, huge difference. So, you have to have some redeployment of people. Okay. You have to have some redeployment of people. So, as I was saying, we will take methods, same method can be used for different purposes, employee selection, employee deployment, employee promotion, everything we can just modify and use the same methods. Okay. So, cluster 3 some redeployment has to be done. Okay. Clear? So, you see, okay. This as I mentioned references. So, thank you for today.